All right, so it's apparently not a very cooperative day here with YouTube and Google, or at least not for Colin and I.
Yeah, the internet doesn't want to work today. So
The
Shy
internet.
again, obviously from the States. It's Colin again from the UK. We'll try again.
Yeah, and I'm trying to update all our posts here just so people get confused.
So yeah, so we're talking about basically the wiring of the ramps. Just giving you an idea of what goes where, just to help you out a little bit. It is tricky. When I wired my first ramps board, I was referencing about 10 or 12 different images, and they're all slightly different, so it was a bit potluck to start with, but I'm sure you were the same way, Shy.
Yeah, it's that was frustrating for me too, because just finding the wrong diagrams or wrong pin connections in different places, just the conflicting information. So if you're like, I was new to it completely. So for me, it was the first time wiring any ramps or any 3D printer at all. I mean, I've opened up my melt seat before on the Wow, but that's still fairly vague.
My first board that I wired was an MKS, which is a dream in comparison to wiring a ramps board. I think the most conflicting information was D8, D9, and D10 connections. Would you agree, Shy?
Yeah, so I think that's because you can use them for anything, though. I mean, there's no. It's not, I think like on the MKS, I don't have one here, but I know like on my Roomba, actually, or on the even on the Melty, it says like hot end 1, hot end 2, heat bed.
Well, it's the firmware that controls it. The firmware naturally controls, is it D9 as layer fan? So you do have to change that if you want to use it for something else.
Yeah, and then in the Repeater, like in the Repeater firmware configurator, I think it calls it like hot end or fan.
Connect.
It doesn't call it at least for the ramps, for example, it doesn't call it D10, D9, D8.
No.
You just kind of have to know that that's the way that's wired.
Yeah. I think the ramps clones have gotten better, haven't they, over time, because they didn't used to come with any sort of notification of what they were used to. Now they say X, Y, and Z, and E0 and E1. So I think they've cottoned on to trying to label it a little bit better than when they first started out.
Well, and I think they used to also even have the wrong cell screen on there too.
Yeah.
Which is worse.
Yeah, definitely.
All right. Definitely. I think I got all the links almost updated. We'll just do one last one here, and then it's going.
I don't know how much the clones differ from the original ramps. Do you, Shy? I don't suppose. I've only ever used a clone. It's always been completely fine. Never had any issues, so I don't know how that compares really to an original ramps.
From what I understand, at least at the version 1.4 and in recent clones, let's say in the last 6 months since I've been buying them, I think the only difference is the poly fuses.
Okay.
I think the original ramps might use either the carb blade fuses or at least higher quality poly fuses.
Okay.
I think that was the only difference that I remember, because I think everything else, maybe the MOSFETs might be a little higher quality.
Yeah.
On a genuine ramps. I know on my ramps, for example, when I'm holding here, the things are like kind of smushed, like the poly fuses are bent backwards and the MOSFETs are bent backwards.
Yeah.
So I think that's just.
I think that's a lot to do with packaging, isn't it, and how things have sent and come off the assembly line.
Yeah.
I've ordered about 3 or 4 different ramp boards now. One came completely smushed, like you say, and one came beautifully upright, and all the rest of it, all the components not been bent or anything like that.
So maybe that's just the other difference is just consistency.
Yeah, definitely. But I've not had any issues with any of the ramps I've had, so you can get a ramps board for about £3 or £4 as well.
Yeah, that's dirt cheap. All right, so I think I got it working now. I think we're good. I was hoping to get some confirmation from Bill, but let me get the chat back open. All right, he says video's back. All right, let me share the diagram and then we can get started again.
Yeah.
Hopefully,
I was just talking to Shy briefly. I'm not sure if you caught it when we came in there or not, about how many members we have in the group now. I think we're coming up to, I think Shy said somewhere between 500 and 600, which is great. I have noticed, I'm sure everyone else has, a lot more builders now.
Yeah, I stopped counting. I mean, I think at some point we had 13. So I mean, I know we're at 523 members. And yeah, I think there was like 13 people building it at some point. Probably now there's at least another 5 or 6 more.
Yeah, exactly. So that's good. That's good for us, because the more people that build, the more people get experience, the more people can help other people. And like anything, it's an exponential growth. So we all help each other, which is the idea behind the community.
Yeah, and I would say just keep in mind, watch the videos. You know, if you guys are new to the group, watch the videos.
Yeah, that's the most common question, isn't it? Like the basic stuff we covered in the videos. So just check out the links in the pin post. I know sometimes on your mobile phone the pin post doesn't come up, but you can find it. It's easy enough. But yeah, like we had one guy said recently joined, commented on there was a lot of information here. In regards to a big build, but that information is only there is because we're all helping everyone. Okay, myself and Shire are sort of leading the group because we were the first builders, but you guys are putting back in just as much. I know Mark is, I know Bill is, I know lots of other people are.
Yeah, we have 42 videos, so
yeah.
You know, we're still going to keep making more. Just let us know what topics you guys want to cover. We still have a list of ideas. We'll be hopefully branching out into maybe some more general 3D printing stuff, but still applies to the ENIAC 40 specifically.
Yeah, I did briefly a quick, which I haven't followed up yet. I do plan to, a quick big build slicing video. I don't know if many people have watched that, but I covered quite a lot there. I've got another maybe 1 or 2 videos in that to continue with, time permitting, over the next couple of weeks.
Yeah. So, all right. So should we get started with the ramps? Hopefully it should stick.
Okay.
If not, just pause every minute or so, and I'll say something, and we'll come back to the screen. But that's the general ramps board for most of you guys, looking at least the way that it should look when it comes properly packaged and not smushed.
Yeah, just be careful if you do get a smush one. Just get yourself some needle nose pliers, straighten out them pins, do it as carefully as you can. It's very easy to snap them off.
Yeah, I usually do. I mean, if you can, I usually take another DuPont connector and just use that. That way, make sure that you grab the full pin, and then you use the needle nose pliers around the DuPont pin.
Yeah, exactly.
All right, so we'll start with the top there. Right, you want to cover that with the E1 and E0 or E0 E1?
Okay, so what we've covered. Well, do you want us to start again or carry on?
Yeah, I'll just start quickly because I had to delete the previous video.
Okay, so let's start with the jumpers. The jumpers for all the stepper motors, as you can see, hopefully from the image on the screen, and 6 pins that are between the long rows of black pin connectors. You've got 1, 2, 3, 4, 5, 6 sets. Now, they're to do with your steps for your stepper motors. Now, the easiest.
Oh, there's 5 of them.
Sorry.
There's 5, not 6.
Sorry, 5. Yeah, sorry, 5. Yeah. Miscounted.
See, that's the thing. It can be confusing, even though you've done this many times.
Yeah,
it can be confusing because there's a bunch of other pins around it.
Yeah, exactly. So your the jumper settings are 6 pins. Now, as we said before, you jumper them from low to high. So what I mean by that is a bottom pin gets jumpered to the pin above it on that picture. So there's 3 jumpers. The easiest way is to put a jumper across all 3 sets of pins, and then it chooses the maximum stepping value of whatever driver you've got in there, whether it's TMCs or whether it's DRVs or whether it's, I can never remember, the 9844s, is it? Or the
84988, I think.
Yeah.
So, but you can jump specifically the pins that are respective to that pins, or that stepping. Yeah, I agree with Colin. I mean, it's not worth it. Just jump them all.
Jump them all, and it's going to pick the best setting. Then you want to put your actual stepper drivers in, the little PCBs. Be very careful when you put these in now. I'd just like to heed a warning. This could go terribly wrong if you don't get it right. It can kill your board, it can kill your drivers, and you end up with completely wasted ramps board. So, the way you put your drivers in. Now, on the drivers, there's a little screw, which we'll be covering again in a bit. But that
let me bring it up here. I'll stop sharing my screen for a second.
Okay. That little screw needs to be on the right-hand side. If you're looking at the ramps board with your power green connectors on the left-hand side, screw on each one needs to be on the right.
Here, hopefully.
Turn the board over the other way.
Oh, okay.
Round 90 degrees. There we go. And so they're looking at it as it is. So as you look, you'll see there's a heat sink, and then there's a little screw on the right-hand side. That's the way you connect all the stepper drivers. Exactly.
Hopefully you guys can see.
Yeah, you can see just on the right-hand side of that heat sink, little silver circle. That's a screw. So that's the way they need to be put in. Okay.
Sure.
Make sure you don't overlap the pins into the connectors next to it. So start off from the left as you're putting your drivers in, and you can't go wrong.
Yeah, you actually can't. You actually can do that. I did see one diagram that actually had the driver like this staggered in the middle.
Okay. So you have to be careful.
Yeah, definitely do not do it this way.
Yeah, exactly. So start from the left, and you can't go wrong. I'd put all your drivers in at the same time, so it's done. And then you're ready to connect your stepper motors. Now, your stepper motors, there's lots of different ways that these diagrams show. But for me, I've always wired. Hold on, let me just clarify. I can't find the blooming picture that I had. Hold on 1 second. Here we go. So the best way to wire them is the wires usually come connected blue, red, green, black in that order. So on one side you've got black, on the other side you've got blue. I usually put them in the connector with the blue on the left. Would you agree, Shay? Is that how you wire yours?
Sorry, so again,
the blue wire of your stepper motor goes to the left, pointing towards the power green connector as you plug them in.
I actually don't remember how I did mine. That's a good point. I think it was the blue.
Yeah, well, don't worry. It's what I've done.
Yeah.
There's lots of diagrams that show. I'm 99% sure that is. If you get it the wrong way around, it doesn't matter. It just means your motor's going to work in the reverse direction. And when you come to put your firmware in, you may spin a couple of connectors anyway. But I usually start, as a preference, blue to the left.
Yeah, so I agree. I mean, you put the blue to the left, right? And if they do end up spinning backwards, you have two choices. Either you go change them in firmware or actually go change them on the board.
Exactly.
So I would just make sure that they're all consistent. So start them all on the left side.
Yeah, so you know
blue, just do blue always on the left. And then if it does turn out to be backwards, either flip them all or just go into the firmware and inverse the direction.
Sometimes no one knows that they actually come off the manufacturing process, sometimes wired wrongly. So that's why. I know it sounds silly, but that's why sometimes you have to turn the connectors around. They're not usually wired in a way that would destroy the motor. They are still wired correctly, but not in that color configuration, if that makes sense.
Have you had that? Have you had that on any of yours, the ones that you've been buying?
Yes, I've had to flip them around or reverse it in firmware.
Yeah, I'm trying to think of mine. I mean, I've used 10 of them so far, I think, and I think mine have all been consistent, at least as far as I can remember. So yeah, it'd be right. We just look up the draw. I mean, even though you have the same brand, you might end up one with the wired backwards from the factory.
Yeah, it's not an issue. You just flip them around or reverse it in firmware if you can't get to your board. So far we've covered jumpers, we've covered stepper drivers, and we've covered connecting the motors to the board. Shai, do you want to carry on a bit?
Yeah. So the next part is the end stops, and hopefully I'll share my screen again. I'll walk through it, and you guys can see here. Make sure I don't crash it again.
Now, there's a lot of conflicting diagrams out there for these as well.
Yeah, so hopefully this sticks. And Colin, I think we'll test this out. I think if I turn off your video, so I think I can do it. I think that way it won't jump back to you. So let's see. Hopefully that works.
Will it still record my audio?
Yeah, it does. Your audio's still there.
Okay, cool.
And I think it actually. We'll see if it works. I think it's actually jumping back to your just a bubble of you. So we'll see if that works.
Oh, right. Okay. So yeah, Shay, you talk about end stops.
So let me cover it here, and I'm looking at my board as I go through the ones here in the picture because I think it's easier to see the picture. So starting from the right there, you have all this bank of 3 here. You'll notice on this particular board here, this 4 pins for the I2C is not filled in. On mine it is. So be careful. I think that's one of the mistakes I made when I originally did this. Is I actually put I put my connectors there. So be careful with that.
What was that, Shay? That didn't make sense to me, and I should have understood that. Say that again.
Yeah, so there's 4 pins here for the I2C on the right side of the end stops.
4 pins for the
I2C, the I2C bus here.
Okay.
So you guys can't see my mouse. Sorry about that. So if you look on the right side of the board, you have the top right corner. Actually, no, let me just switch back to mine.
Yeah, you have 1, 2, 3, 4, 5, 6 sets of 3 pins.
So let's see. Hope you guys can see it better. So there's the end stops are right here.
Yeah.
Right, and then you have on mine, you have the I2C bus here. There's 4 pins right there.
Yeah.
So as I was saying, is be careful, because on mine, when I actually did it originally, because I wasn't aware of what I was doing, I plugged my end stops into that I2C bus. So just pay attention that there is this bank of 6 end stop pins there.
Yeah. I usually say when I wire my ramps, I always start from the left. So you usually can't go wrong if you start wiring anything you do on your ramps board from the left-hand side, as long as you've got your power connector on the left-hand side to start with. So
yeah, so let's go through the actually wiring the connections here. And let me go back to the diagrams. I think that's easier to see.
Okay, so pretty much you've got end stop min, end stop max for each axis. So you've got X, Y, Z, all got min and max. So that's 6 sets of pins. Shane?
Yeah, so you have the first one's the X min, then it's you don't use the next one's X max, and then you have Y min, Y max, and Z min and Z max.
Yeah, be careful, because there's some diagrams out there that reverse that order, that call them the wrong way around.
Yeah, I agree, and I think there's some ramps even that are silk-screen wrong too. So okay. on mine and other ones I have, I mean, they're not even labeled X min or X max, because
no, mine aren't. Or if they are, they're that badly manufactured that the letters are underneath the connectors and you can't read.
Yeah, I know, it's true. So yeah, keep in mind. So starting from the left again, X min, X max, Y min, Y max, Z min, and Z max.
You usually find, don't you, Shy? I'm sure you'll agree that any sort of labeling or any sort of pin configuration is usually in the realms of X, Y, Z. X, Y, Z. Same with the steppers, always set out usually in that format.
Yeah, so you're right. And I'm going to try to pull up what my idea was, if we could do diagram while we work on this. We'll see if this works.
I'm seeing something.
Yeah, that's half cooperating this morning. Hang on.
Don't be putting any passwords in.
No, I know. I almost did that. I had this up before until it crashed.
Yeah, so why Shy does that? So again, we'll get into end stops. The way we're talking about this is the way I wire my board when I'm constructing a printer, in this manner. It's logical, it's easy to get to the connections, you're not fighting around anything if you do it in this manner, and it's just the easiest way to do. So it's steppers, motors, end stops.
Yeah, I'm just pulling the diagram in here, so that'll help. Because that's hopefully the idea is that we get this labeled.
Maybe we should create our own diagram, Shy.
Yeah, that's what I wanted to do. I know Bill had asked us for it on the group there. And I think Mark was starting to work on one.
Okay.
So at least hopefully this will help. I'll do this quickly here and draw.io. I think I can link to this later so you guys can see it. Hopefully it's not too confusing.
Yeah, because so far the drivers are self-explanatory as long as you get the boards mounted in the right way.
Yeah.
It says on the ramps board it's X axis, it's Y axis, it's Z axis, it's extruder 0, it's extruder 1.
Yeah, and actually, I was thinking about it too. Is I totally agree with your comment about using the MKS if you're just starting out, because the MKS has all the stuff labeled.
Yeah, it's literally it's labeled. You can't go wrong. It's got slightly different connectors to the ramps, but nothing that would cause you any issue.
Yeah, so I mean, if you're starting out, probably use MKS or Roomba, or even I think the G-Tech boards have them.
Yeah,
and LT.
But then you've got ramps and its cheapness and its effectiveness.
Oh yeah,
ramps works. It's dirt cheap. It's easy to sort out. Most people who've had any problems have usually posted about it, so you can solve them yourself. So I had I had an Arduino that its voltage regulator died. So in order to get power, I had to bypass a diode on the ramps board, which I unclipped, which is easy. Lots of documentation to do it, and I got my system up and running. And then when I sorted out my Arduino board, I then just reinstated the diode and off I went. And that's because it's so it's used by pretty much everyone. I'm not saying it's the best way to go about or the best board to use for a printer, but it's effective and there's lots of documentation out there. But the trouble is, like I say, a lot of it's wrong, but some of it's right.
I mean, technically, I guess it could be right if that's the way that they did their firmware, but the way that they're doing their firmware isn't even like the common way to do it either.
Yeah. I feel the way we're wiring this is usually the common settings in the firmware without actually having to change anything in rep.
Yeah. So, okay. So hopefully that helps. That's at least a start to labeling them. Hopefully my arrows are close to the right way, and I'll add the X max and Y max and Z max in a minute.
Yeah. So
that's the end stop wiring. We do use the out of filament sensor, as well as what else do I use it for? So I think in my case my low filament sensor is on the Y max, I believe, or the Z max.
Mine's on the Z max.
Yeah, so me too. I'll double check the firmware in a second.
Yeah.
Again,
it's a firmware choice. You have to enable filament sensor, and then you have to choose a pin configuration that you use. But because you're using an end stop switching effect for it, you might as well use an end stop pin. So therefore, you just pick one that's not being used.
Yeah, that makes it much easier. I'm gonna try to see if I can find the firmware quick.
Okay, so we've wired the end stops. We've wired the stepper motors and the stepper drivers. Now we probably want to look at wiring the hot end, I would say.
Yeah, so that's going to be the D stuff on the left.
Yeah, right. So we're looking at D8, D9, D10. So let's start with D8. Now, D8 is only usually used if you have a heat bed, or you can set it as a, without getting too complicated. I'm not going to get too complicated by talking about second extruders and stuff yet, because I'm assuming if you watch this video and you need this information, you're not that into dual extrusion yet. So D8, if you've got a heat bed, is what you use the power to power your heat bed. So you've got negative and positive. Really easy. Screw terminals, screw it in, done. Now, because if you're wiring a heat bed, you've usually got a thermistor coming from that heat bed to tell the LCD or whatever way you have of viewing your printer feedback on the temperature of that bed. Otherwise, it would just heat up and explode. Well, not explode, but melt. So the thermistor wires into. Should we cover that now, or should we carry on? Do you reckon?
Wait, so when we covered the, I was looking up the.
So we've just covered D8, but obviously along with that heat bed, you have a thermistor. Now that plugs into. If you're looking at the diagram, have we got the diagram up, Shay?
Yeah, it's the
diagram. Okay, so you've got the end stops. Then you've got three metal things. I'm not that electronically minded, so I think they're capacitors of some sort. Three silver things. And then you've got another row of pins. There's 2, 4, 6 single pins. Okay. Now here those are where you wire your thermistors. Okay. Now the wiring for the bed thermistor is usually the middle 2. Okay, the middle 2. So as you look at that diagram, the one pin is, it doesn't matter which way you connect it round. I'll just put that out there. Your first pin is pin number 3 as you count from the left. The second pin is pin number 4 as you count from the left. So the middle 2 you'd connect your thermistor to. That's the heat bed dealt with.
Yeah, so it's actually it's labeled on the board as T1.
Okay. Okay. Cool. Okay. So I didn't notice that on my ramps that they were labeled.
Well,
okay,
yeah,
cool.
that depends. Assuming that your board is labeled.
Okay. So then we go on to D9, which is the blue connector or the green connector
Hang on, let me catch up with you on the diagramming here.
Okay.
Yeah, and it's worth to call out too. The important part here is what Colin said, that the direction on the thermistor doesn't matter, and neither does it matter on the heat bed connection to D8. They're both non-polarized.
Okay, I didn't know that personally about the heat bed. I know it didn't matter with the thermistor, but I was unaware that it didn't matter, because obviously when you've got a heat bed, you have a positive lead and a negative lead usually.
Yeah, I mean, on the board itself, it'll usually say that, but technically it doesn't matter because they're
it's just current passing through it. It's a circle of current, isn't it, in effect?
Yep. All right. Hope that makes sense. I'll fix the lines here later.
Okay. So we've done the heat bed in D8. We've done the thermistor for that heat bed. Keep in mind we're talking about the heat bed still, not the hot end.
Yep.
So D9. So D9, this is where there's a lot of confusion. D9 is naturally set in your firmware without changing anything, if I remember rightly, to your layer fans.
Yep.
Okay, your layer fans. So that's basically any fans you set up for pointing towards your print. So you might have a couple of sets of wires that you wire in here, because if you're anything like me or Shy, you have a couple of fans pointing in both directions towards your print. So it's pretty simple, positive and negative. Now it does matter that you get these the right way round. Okay, it says on the board positive.
You might blow up your fan if you don't do it right.
Yeah, exactly. So again, just being stringent, take your time. Red's positive, black's negative. And why you have two fans or a single fan, maybe blowers, maybe whatever. As long as they're 5-volt fans, it's fine. Is that right? 5 volts? Are they 5 volts? Are they 12?
No, 12 volts.
12. Sorry, my bad. 12-volt fans. So that's pretty much simple. That's your layer fans dealt with in D9. Nothing else to worry about there. So D10. Okay, D10 again is for the heat cartridge on your hot end. Now, you usually find they come in like a fibrous, if I remember rightly, they have a fibrous coating to the wires, the heat protection coating on the wire. Now, again, I'm not sure if it matters, but I always make sure black to black, red to red, red to positive, black to negative, same difference.
Yeah, I mean, I agree. If they're actually colored, the red and black, then yeah, put it the right way. Just
even if it doesn't matter, it's just for ease of looking. It may confuse you if you see a red in a black connector, a black in a red, so on and so forth.
Yeah, but technically, I mean, from a technical perspective, it doesn't matter. But I totally agree. Just to keep consistency.
Yeah, Shy's a bit more clued up on the technical side than I am. I like to dot I's and cross T's, and he's the same, but he knows a bit more about it than I do. So we've now wired in the heat bed thermistor, the layer fans, and the heater cartridge for the hot end. So basically that's a little cartridge that sits inside the little aluminium block that's clamped into place. So the next thing we wire up, because obviously if you have a heater cartridge in your hot end, you need to be able to tell what temperature that is and control it. So you have a thermistor like you have for your heat bed. Now this thermistor goes all the way to that 6 set of pins again where you wired your thermistor for your heat bed, but your thermistor for your hot end uses pins 1 and pins 2. So as you count from the left, pin 1 and pin 2 are your connectors for your thermistor for your hot end. So out of them 6 pins now, you should have something on pin 1, pin 2, pin 3, and pin 4.
Yeah. So here, we'll pause for here. Let me go through again so you guys can see the diagram here. And I'm drawing the arrows as we go along. But as Colin said, the T0 is the heat cartridge thermistor. That's the first set of 2. Then you have the heat bed thermistor, which is the second set of 2. And then you have going on the left side, D10 is your heater cartridge or your extruder 0. D9 is your layer fan. which polarization does matter here. Make sure you get your plus and minus the right way. And D8 is your heat bed. So again, that matches the way we have the firmware set up. And then go back to the end stops. You have the X min, you have the Y min, and then you have the Z min. So again, it's Y min, X min, X max that we don't use, Y min, and then Y max that we don't use, Z min, and then Z max that we don't use. And I just double checked in the firmware, at least that we posted, we have the extruder jam detection or the out of filament sensor on actually the X max. But as Colin said, you can easily just change it in the firmware, either in the firmware itself or in the configurator, to have it like he has it on Z max.
And of course, just to be fair, we did do a walkthrough of the firmware. Refer to that video, and that will guide you through the firmware as well. So you basically were holding your hand as best we can through the process. Once you've done it once, trust me, it's not that scary. You'll be able to do it again on your own next time.
Yeah, so let's cover the power stuff, because I know that can be confusing too.
Yeah, definitely. So this is the last set of connectors. Oh no, we've got the LCD, but we'll cover the power first.
Wait, did we say about the steppers? We talked about those going to put them in the right direction.
Yes, yeah. The screw on the right hand side on the Allegros. Is it the same for the TMCs and DRVs, Shy?
No, that's the VREF. Yeah. So on the actually no. So on the that's an important note. So on the let me switch back here. So mine. Hang on a second.
I did mention to make sure that the screw was on the right hand side when you put the stepper drivers in.
Yeah. So as you can see, what Colin said. I don't know if that's reversed for you guys, but the right hand side. Colin, is that the right for you?
No. Turn it other way around.
All right. All right. So as Colin said, the screw or the VREF adjustments there is on the right side. So when you actually use the DRVs, it's going to be the other way around. So it should be on the left side.
Oh,
and same thing for the TMCs. It's on the left side as well. So if you actually do put it backwards, yes, you can screw up your board too. The way that I always do it, just to make sure, because again, if you buy any of the clone stuff, right? So if you're buying from China, I would still double check on both the Allegros and the DRV and the TMCs on any clone. Look at the bottom. You guys will not be able to see that silk screen, I think, but that's gonna be way too small. I thought it'll come clear. But you can see there's a silk screen on the bottom there. Make sure that you're looking at find a ground pin, and that ground pin is what should match to the pin out on the RAMS board itself. So in that case, the way that we were showing before, let me get my orientation right here.
Your probably best way to look at it is your Allegros right, your DRVs, your TMCs left.
No, well, you can't rely on that, because some of the clones are backwards. I had one set of DRVs that not DRVs, sorry, one set of Allegros that out of 6 or 5 that I bought, the VRF screw was actually on the wrong side.
Okay.
So I didn't use it, I just threw it away. But you basically want to make sure I'm looking at the board here, and I'll double check this and we'll put the diagram. But if you hold up the Allegro this way, right, Colin, that's on the right side again. I just want to try to keep consistent here. Okay. All right. So if you hold it up this way, the ground on the back of the Allegro itself is the top right here. You see my finger is? So it's right above the screw terminal. That's the ground pin. On the DRV's example, in this case, the ground pin is on the top right again. Right? So let me put it in here just to show next to each other. So you guys can see that as Colin said before, the VREF screw is on the right side on the Allegro, and on the DRV it's on the left, and then same thing on the TMC, it's going to be on the left side. But the ground pin on the back is always going to be the same thing. It's going to be in the top right corner. So again, when we finish out the diagram, we'll put that detail there, just to make sure everybody's clear.
But this is a big deal. If you don't get this right, you'll fry all your electronics. So my bad. I sort of said, yeah, little screw is always on the right. It's not. It depends on what driver you're using. The reason I said that is I've never really used any different drivers than the Allegros. Shai has a bit more experience of that, so just be wary. If you're unsure, post a question. One of us will get to it quickly.
Yeah, so I mean, but you're right though. It should be consistent with the. It should be consistently done that way. The way that we'll put it up, the way that we'll put it in the diagram is the way that it should be done. We'll just note there about the ground pin just to make sure that you do double check that to be right. All right, so the power connectors. So I think that's the last thing we have left to cover.
An LCD.
Yes, an LCD. So let's do. Should we leave the power for last because it's the most complicated one?
The power.
Yeah, because the LCD I think is easy.
Really?
The LCD.
I thought
LCD
power's easy.
Power's easy. Okay.
Okay. So ask yourself: do you have a heat bed or not? If the answer is yes, you wire up both supplies from your amps board to 2 supplies from your power supply. So if you count pin 1, I'm not sure quite how they're labeled on the ramps board, but if you count pin 1 is the screw pin right at the bottom of the screen. Pin 2, pin 3, pin 4. So 1's negative, 2's positive, 3's negative, 4's positive. So there's 2 sets of supplies. There's a negative and a positive, and negative and a positive. They need to go to 12-volt supply from your power supply. Both sets, 2 separate sets. If you don't, you'll come into issues. If you're not running a heated bed, I believe it's just pins 1 and 2. But to be fair, it wouldn't hurt if you wired up the second set. So as a rule, wire both sets up to your power supply. Most power supplies have lots of sets of connectors. So wire both sets up.
Yeah, so let me go back to the diagram here and I'll bring it up so people can see. The other thing to note too is just if you're curious about the fuses and how the fuses are actually set up, the bottom is the 5 amp fuse. The one down here that's for the extruder and the step for extruders and extruder and steppers, and the top, the heat bed one, is the 11 amp fuse. That's for the heat bed. So as Colin said, make sure you do wire both. There is, I don't know, Colin, if you saw it, but there's some diagrams that actually show a jumper pin going from the extruder from the bottom 2 pins to the top pin, where they did one set of wiring for the power supply. Yeah, I did come
across that, but I've never used it. I don't know what that's for, whether it's to stabilize the power supply or what.
No, it's already
be getting 12 volts.
I think, yeah, I think it's, I mean, to me, I think it's just being lazy, for lack of better words, because what you're doing is you're basically running both the heat bed and extruder stepper then off of one set of wires that are going back to the power supply.
But so if you're using,
yeah, so if you're using actually like 16 gauge wiring, which is what we generally recommend for most of the stuff, that's actually not enough if you're running both the heat bed and the extruders off of that one.
So as a rule, just wire them completely separately. 2 lots of wires coming from your power supply to both sets of connectors.
Yep, and then just again, even though we kind of didn't mention this before, but we use the solid state relays for the heat bed, right? So the heat bed in my case is mains. Colin, yours runs off of a separate power supply.
Yeah.
Right. So even if you do that and you have it going through an SSR and your power is not going through here, I would say still wire the heat bed connector here with the proper 16 gauge wire going back to your power supply. You don't have to, but again, I think just for being consistent.
Because then that way, whenever you wire a ramps board, you will wire it the same way every time without having to think about it.
Yep, I agree, because that definitely, you get that mindset of doing it right every time.
You can't I don't know how many you wired, so I think I've wired 4, possibly 5 now. That's without the wiring and rewiring when I've taken stuff apart.
Yeah, I think I've done 3.
So it's natural now. I don't really have to think about it because I wire it exactly the same way each time. So
that'll be fine.
That's pretty much it, apart from the LCD. And that's pretty easy. They're labeled 1 and 2, if I remember rightly. And your LCD's labeled. Oh, no, so I'm jumping ahead of myself here. Okay, start again.
Yeah,
so with your ramps board, you have a separate connector which plugs into the big line of pins on the far right-hand side.
Yeah, so let me bring up one of the diagrams here that shows it pretty well.
Oh, yeah, there's one there that was.
Nope, that's a small one.
No, come out of that, and if you go 2 rows down.
Oh, here.
That red one left.
That one?
Yeah, sort of, but pull your screen up. There we go. So there you go. So that's what it looks like. The little separate PCB, which will connect your LCD wires to your LCD, but that PCB plugs into your amps board. So that PCB will have labels on it, 1 and 2. Is it LC1, LC2? I can't remember how they label it, but
No,
both, but you might find some are 0 and 1. Doesn't really matter. If they're labeled 0 and 1, 0 is equivalent to 1, 1 is equivalent to 2. As long as they're succeeding each other, that's fine. You'll plug on the back of your LCD, they'll be exactly the same. It'll be 1 and 2 or 0 and 1. You correspond the connectors to the same connector. So 1 to 1, 2 to 2, or 0 to 0, 1 to 1, or 0 to 1 and 1 to 2. I know that sounded a bit confusing, but if you listen to it, it's pretty basic stuff. So at that point, once you've wired it in, your LCD separate PCB just slots into your ramps board. You can't go wrong because you can only get the pins right on this. Otherwise, certain pins are not connected. So as long as both black strips have a pin going into it, you can't go wrong as long as you're putting them down the right hand side of the PCB of the ramp. So you can see there, you got the row of pins and then your row of pins at the bottom.
Yeah, so that covers the, because LCD hooks into the aux 3. You actually even on the ramps use the aux 1 and 2. So there's I saw some
on the label auxiliary 1 and 2.
Yeah, auxiliary 1 and 2. Yeah, so there's some diagrams out there will actually have you not using that PCB board and hooking the LCD directly to auxiliary 1 and 2. Yeah. I think if you do that, it might work, but I think you actually have to change something in the firmware for the pins. So it's easy. I agree with just totally use the that breakout board.
I don't
for
think
the LCD.
I don't think you can buy a ramp without it. To be fair, so I think you usually get that breakout board, don't you? Everyone I've bought, I've got it. So you might as well use it to save messing around. And again, the same habits, wiring exactly the same way each time.
Did you have on yours where the LCD wouldn't turn on? You had to flip one of the cables backwards.
That's only to do with the MKS. Okay,
did you mention that? Sorry, I stepped away for a second.
No, but that's the MKS board. An MKS board to a regular LCD, so that doesn't sort of apply here.
Yeah, but if you choose to use an MKS, it's worth at least knowing that you might have to flip one of the wires around.
Okay. Okay, I wasn't sure if we was going to do something separate for the MKS, but I suppose there's no need because the MKS is self-explanatory. So, like I said, MKS board, which is quite a popular board. It's what I use for my ENIAC. So everything's labeled. You can't go wrong. Connectors are slightly different. Fine. But if you're using a regular LCD like the 12864, I can't remember exactly what you call it. You have to turn the wires around because for some reason MKS like to wire their LCDs slightly different. So the way I did this is there's a little notch on your LCD cables. I filed down that notch and just turned the connectors round.
Was it both of them?
That's a good question.
I can't remember. I think it was one of them. I don't know which one.
One of them. Let me just check.
Yeah. So how about this? We'll look. We'll probably do. So this is the ramps diagram. We'll do another diagram. I think just for the MKS, just to help out.
I think it was both.
Okay.
I think it was both. But don't quote us on that. We'll double check that.
Yep. And just to go back to I think we covered everything. I just want to go back quick to the heat bed, and then we can talk about some accessory stuff for the future for a bit. But the heat bed in this case, we'll draw out the connection to the solid state relay, and we'll draw out the two different options going to the single zone solid heat bed, which I think is the cheapest and what I'd recommend at the moment. And then I'll do the diagram as well for the dual zone heat bed.
Yeah, because obviously the heat beds for the ENIAC, which obviously this probably relates to more than anything, although it relates to any printer really. It's usually a separate heat bed system we've gone for because of the sheer size of it. Like Shai said, he's used a 120 volt power supply one. I've used a separate printer power supply, 112 volt one to power mine. So there's a couple of options out there, and it's a little bit tricky to get the wiring right, and it's very tricky to get a decent relay that won't burn your house down. So be very careful.
Yeah, and I'm just looking up right now the LED power supply, because Bill is just messaging that that's what he's concerned about, is actually wiring up the power supply properly. So let me find a. Look for a decent picture of a power supply. We can use that one.
That's fine. That looks. So pretty much you have a live, neutral, and earth to most power supplies. In the States, I don't think you. Oh, you do have the earth. You do have the earth. So you wire your mains wire, plug that goes into the wall, to your live, neutral, and earth. If you have an earth, do you have earth in the States?
Yeah, we call it ground.
Ground, okay, ground. And then obviously on the other side of the power supply are all your 12 volt connectors, your minus V, your plus V, your minus V, your plus V.
Yeah, okay, let me put the picture in here so they can see. One thing I probably should caveat when we start talking about power is we're recommending the way that we connected it and what we suggest doing, but just as a disclaimer, if you blow up your house or catch fire, yeah, it's not our fault.
Yeah, exactly. Anything you do here, guys, you do off your own back. If your ramp suddenly decides to burst into flames and sets your house alight, it's your own liability, I'm afraid. We're just guiding you through what we've done, not necessarily what you should do. If you choose to copy us, then that's down to you.
Yeah, just double check everything, make sure you know what you're doing, and read up on these things too.
Yeah.
Don't just ever blindly wire. I mean, I would say that probably about anybody. Don't just blindly follow what they're doing without understanding what you're doing.
I myself, I consider myself quite experienced now in wiring up boards for printers. But before I put that power on, I walk away from the printer. There's no point checking your wiring straight after you've wired it, because you will look at the same errors the same way. Walk away for a couple of hours, come back, check your wiring one more time before you switch it on. It takes 10 minutes, and it could save yourself a lot of money in damaged electronics.
Yeah. Those can hurt.
Yeah. Yeah, exactly. We're playing with 120 volts in the States and 240 in the UK or Europe. So yeah, it's instant death, guys. We shouldn't mess around with these things. You've got to know what you're doing, and again, disclaimer: you do so at your own risk.
Yeah, sorry, we should have thrown out in the beginning there, but hopefully you guys notice it. All right, so just trying to put the lines over the right way here.
Yeah, so you got minus V plus V on one side of power supply. They're your negative and positive that you connect up to your two connectors. And one thing we have forgotten, we need to go into connection of the hot end fan.
We covered the hot end fan. Yeah, you're right. You want to cover that real quick while I'm doing this?
Yeah, while Shay's doing that. So your hot end fan, we're going to be bringing out a way to control that via firmware. But for now, you need that plugged into a permanent 12 volt supply, because the minute you switch your printer on, you want that fan running. Okay, we are going to control it via firmware, so it only starts running when your hot end gets to a certain temperature. But for now, you just want it plugged into a live 12 volt supply. So you can plug that into the green connectors. I don't know if Shai uses whether there's 12 volt supply anywhere else on the board, but
yeah. So it depends on your ramps board, because if you look at the drawing here, so if you look towards the right bottom of the polyfuse and the left side of the little reset button here, there's 3 pins. So those 3 pins are actually 5 volt, ground, and 12 volts. And so if you wire up actually I think that's right, I'll double check, but the top 2 are the 12 volts.
Yeah, so you can wire up your extruder fan, which needs to be permanently on, because you don't want your filament heating up inside your heatsink and clogging up.
Yeah, so you can wire it there. That's probably the easiest way to do it, or in the actual green connectors, I call into two.
But you start getting into problems then with too many wires going into connectors and stuff like that. So there's ways of doing it better, but for now, that's the easiest way.
I'm actually trying to see it. Those bottom three, I think actually the 5-volt. This board that I have is missing the two top ones. So I think these two top ones up here are the 12 volts.
Okay.
I'll have to look at the pinout. I know you guys can't see the mouse, but or can you guys see my mouse or no?
I can, but I don't know whether they will. Can I?
So,
yeah.
So if you look here where the crosshairs are on my mouse, I think it's actually labeled wrong on this picture, but this is the 12 volts up here, these 2 pins, and I think these 3 pins down here are the 5 volts. So it should be these top 2. Again, I'll double check before.
If you're unsure, plug them in one of the green connectors. It just means you've got a couple of wires going in until you clear it up, like you may be wanting. Bill, I know you're eager to get wiring because it's been holding you up a bit. So today, if you want to just crack on, plug it into the green connectors. You've only got 12 volts going into them green connectors. You won't kill yourself off them green connectors. But guys, going back to the power supply, you've got 120 volts or 240 volts going into the live neutral earth connectors. Me personally, I like to print a cover to cover up those connectors. I have kids in the house, wandering fingers. The last thing you want is anyone touching those connectors. Okay, so build yourself an enclosure or pull it somewhere out of reach or whatever you got to do to make it safe, but make it safe. You're playing with 240 volts or 120. And
yeah, I'm trying to find a picture of the kettle switch, or it's called the kettle switch or IEC fused outlet. Trying to find one that looks like what we used here. So I want to find the back in front of it because I know Bill was asking that question before. It's this one. Steal. I'll find Creative Commons pictures later, but for now I'll use these.
At the end of the day, I'm not trying to scare you because it's easy. I've wired umpteen, Shai's wired umpteen boards, but just be careful.
Yeah. So I don't know if you use the if you use these kettle switches.
I didn't know. I just printed covers on my power supplies, and the only way I am able to switch my printer on and off is by plugging it into the wall, which isn't ideal. I know I have got to design some sort of switching system or start using what you're using there, Shai.
Yeah. So this is actually the picture of the fused switch, and I'll find the wiring. I had it the other day. I'll find the wiring again if I had actually wired this properly. But the idea is that there's a fuse there and you have your plug coming in. And like Colin said, there's actually covers that you can print. I have one that I'm going to test out the next day that I think we'll update, that you can cover it up. And then you have your just standard 120 volt or 240 volt plug going into here. And then you're not cutting up any 120 volt wires and having bare connectors. And the nice thing is then you just run these wires from here to the power supply and then cover it up nicely, so that way it's not sticking out anywhere. And then you also have a fuse in here too.
Yeah, I'll tell you what I do like, which I've just noticed, that power supply you've pulled an image of. Yeah. That looks quite an effective power supply because there's lots of airflow going into that power supply.
Yeah, it's actually, and it's not the one we have on the bomb, I think, because there's different ones. There's ones that have the 3 positive and 3 grounds.
Yeah. Because that's what I've got. So, I've got 3 sets of connectors.
Yeah, I wouldn't get the ones that have 2 or the ones that have. There's some that have 1 too.
That's another thing, guys. Going back to your fan for your hot end that wants to be on permanently at the minute till we come up with this new option of firmware controlled, which Shai is currently testing out. You can use a set of connectors. If you have 3 set of connectors on your power supply, you can actually wire straight to your power supply as long as it's 12 volt side.
Yeah, actually, that's a good point. We talked about, I think you and I talked about a fan bus at the beginning.
Yeah.
Because we have the extruder, we have 2 heatsink fans, yep. Right? And then we have 2 more fans on the X and Y.
Yep.
And then you might have other fans. I have a board cooling fan as well. So I have 5 fans. Yeah. No, I have 6 fans actually, because I have two board cooling fans. I have one for the Raspberry Pi and then one for the other one. So I have 6 fans in total. So I don't know if you did too, but I created like a bus basically where I have 2 plugs going into the positive and negative here, and then going to like a bus panel for the other fans.
I
draw that out too.
Yes, I definitely recommend it just for ease of wiring, because it's all well and good to get it up and running, but the minute you want to do any maintenance, if a fan dies or anything like that, it's a nightmare. So a bus board or a breakout board is definitely worth using.
Yeah, I agree. I actually didn't think about that. I like that better than using the 12 volts on the board.
Because that's how I've got my fans wired in. They're straight to the power supply. Because if you remember, guys, I've got 2 power supplies, one running my heat bed, running my electronics. So I've got more than enough connectors, a 12 volt, like raw connectors, as I like to call it.
Yeah, I'm just pulling up the fans too. If you do have one of these, I'm actually going to use this picture intentionally. If you have a 3-wire fan like this one, you could just actually cut the yellow wire. The yellow wire is the
control fan, isn't it?
Yeah, it's a control wire, but you don't use it because it's actually controlled by the board itself.
Yeah. And just to give you the thing, it dictates the power the fan receives, so that dictates speed rather than a control system. So I think that's it. Would you agree, Shai?
Yeah. Let me think. We cover the heat bed, the extruder.
Don't think.
Yeah, still finished drawing out some of these other things. Yeah, I mean, we can. I can briefly mention if you're using any servos, they go here in the bottom connector here. We won't cover it in detail because we're not using them today. But any servers for auto leveling, wiping, all that kind of stuff that we're going to talk about in the future, that's going to be used. The servos here. The LED lighting that I have, that's actually controlled by firmware. I'll cover that again in another video, but that's also connected to one of these aux pins to a relay. So that's how I do the LED lighting. I'm not done yet, so I don't want to go into detail right now, but I'll add that later on. Let's see. Yeah, I think that covers everything.
Obviously, everyone has their own nuances and the way they add certain things or they want certain things on their printers. Like for me, I like to print cosplay stuff and helmets, so the filament sensor was the first priority for me, which succeeded in doing.
I'm gonna put that on here though, because I think you should, with this as a printer, I think you should connect the out of filament sensor.
I agree. I think you can't really function without it, because when you're printing at that size, it's very easy to go for a reel of filament in a single print. I did a 7-day print recently that was just over 2.5 kilograms. So I went for 2.5 reels of plastic. So it was invaluable for me. There's no way I want to sit there watching it till it runs out.
Yeah, so I mean, for now, we're going to put on X Max. I know we don't have, the one I'm using is actually one that I bought off Amazon. I went through printing like 10 of them and I couldn't get them to work. Colin, I know yours works pretty well.
Yeah, mine works perfectly. I've never had a single issue with mine. Works absolutely flawlessly. I don't know why that is, because Shai had such issues with his. I don't know if it's just so happens it was the switch I used or the way I mounted it or what. I'm not 100% sure, but it just works. So I can always do a video on it in time to come, a little 101 or 102 video, just to sort of show people how I did it.
Yeah, I think if you can post your STLs and then we'll add it to the bomb.
Yeah.
And that way people can try to go that route first, and then if it doesn't work out for them, just buy the one off Amazon. I'll add the link there too.
Yeah. Was the Amazon one expensive, Shai?
No, it's $25.
How much?
25.
45.
No, 25.
Ah, 25.
I mean,
that's expensive.
It is in comparison to what you can print out and make. Then I agree it's expensive, but I got so frustrated with mine I couldn't get it to work.
Yeah, for you, the time was worth the money, wasn't it, for the time spent?
Yeah, I mean, I spent so much time designing and printing and testing out different ones, and I had so many false positives. It was so frustrating. So I did buy the one off Amazon. The thing is, actually, it's a pretty simple design. So I have all the parts to actually make one.
Yeah.
I just haven't done it yet.
Because I've never had a false positive, and I don't know why I haven't. It must be the case I printed. It must be to do with that, mustn't it?
I printed yours too, and I had issues. So it's just my luck, probably.
Yeah. I'm just going to throw that out there, guys. Shai has the most awful luck when it comes to printing. If
Oh
it
yeah.
can go wrong, it will go wrong.
Yeah, I'm looking at all the parts that we have here on the thing, and I think I've broken every one of these at least once.
Yeah, we've had conversations about everyone, which is why we probably know as much as we do, because we've had the issues and dealt with them, haven't we?
Yep, I've actually had this the switch on the IEC panel broken too.
Yeah, I remember you saying about that. Didn't they die all at once? Was it one or two of them?
No, it was one of them died. I decided to stop working. Thankfully, it failed in the off position.
Yes, that was right, because we'd agreed that maybe failing on wasn't the best way for it to fail.
No. All right, guys. So we have. I think we walked through everything. I mean, I'll finish up this wiring here. If you want, we can just keep the live stream going. If you want, just
yeah, just for a few minutes.
Yeah, if everybody has other questions.
Other stuff we plan on sort of trying to work in. Shai's worked a lot on the firmware side of stuff, like firmware controlled hot end fans. Obviously, we've spoken to you about the filament sensor, which is pretty much there. And just generally being able to control every element through firmware is the way forward for us, really. Like firmware control of the hot end fan, firmware control probably of ramps and Arduino or MKS or PCB boards, control of those, and pretty much just trying to have being able to adjust anything we need to adjust as we go. I don't know if you can think of anything more, Shay. I know you're busy trying to get that diagram done, but
yeah, I mean, I'll just for clarity too. When we say extruder fans, we're talking about the heatsink fans.
Yeah, sorry, heatsink fans.
Cool. I know some people get confused. So it's the ones that cool cold end, right? The idea with firmware is that you can only have them on when the hot end is beyond a certain temperature. So like one of my other printers that I do have it working on, the fans are completely off when the printer is not printing.
Which is good, because when you print finishes, am I right in thinking when you print finishes, mine sounds like a nuclear reactor with just the fans on. So that would stop them, because your temperature of your hot end would drop to a certain level, the fans would go off, so then your printer becomes quiet. Which is
correct. Same thing for there's a board cooling fan too. So even the same thing that the board cooling fan doesn't come on until the steppers start working.
Yeah, so all that stuff Shai's sort of been looking into. Well, we've both been working on a sort of side project, haven't we? Which we're probably going to release some news about at some point in the next couple of months, which is quite exciting. So although we haven't been, well, I think we're still pretty active on the group. We are working on other projects as well, which we're looking forward to bringing to you guys, and hopefully it'll be of some interest to you.
Yeah.
And if it's not, it's not. But we'll still be here on the ENIAC 40 page doing what we do.
Yeah, I think we're just trying to find ways to make the ENIAC 40 Ultimate better by doing other things.
Yeah, exactly.
I mean, I'll say auto leveling. I know a lot of people asked about auto leveling.
Yeah,
it's a pain in the ass.
It's a minefield, or an absolute math minefield before you get to anything else.
I mean, just to give you guys an idea, Repetier is frustrating because I've been talking to the developer a lot, the main developer there on the boards, and the main branch of Repetier itself does not support auto leveling for anything but a Delta, because you always have to home to Zmax, which is a pain, even on a small printer, for auto leveling. But just as of recently in the development branch, they've actually talked about they've actually changed it over to homing to Zmin, which is still a bit buggy, and we're working out I'm helping them work out some of the bugs in the Zmin stuff for auto leveling. And testing out a BL Touch, I had a regular inductive sensor before, so there's a bunch of nuances. I'll probably do a separate video just on talking about auto leveling. Real quick, Bill asked, how do you ground when you have a black anodized frame? I think I'll take that one. Bill, you really can't. So the problem is, I guess you can if you think about this before you start to build.
Yeah.
So the part is because of the black anodizing. Let me turn off the share for a second. And Colin, you actually helped me out with this when I was doing it too, so appreciate that. So let's just say I have my 2 minutes. So let's say this is one part of a 2020, and you have another part of 2020 here. So when they're actually the black anodizing on this one, even though this 2020 on this end is naked, so to speak, raw, when it's touching the black part here, there's no connection. So they actually cannot touch it and make that connection. So you can't properly really ground the frame.
But
what I did on mine is
that though is that it's only going to stay if for some reason power gets to it, it's only going to stay within that one section.
Yeah. So what I did is I grounded, I sanded or shaved off part of the black anodizing on one of the bars, and that's where I grounded it to. So I know that's not the best, but that's the way that I did it. The other ways you can do it is if you actually, so if you have the vertical piece and the horizontal piece butting up like that, you can actually drill a hole on this side and screw through that bar to the other bar, and the screw will be your connection point. That is a pain to do because if you don't have it accurate exactly, you're actually going to offset your 2020s.
Yeah.
And you can actually get them pre-drilled from like Misumi, but you're paying I think like another $2 or $3 per drill hole.
Yeah.
So that
I think really what you got to think about that if you cannot insulate the whole frame, then because it's already insulated by the what do you call it, ionize or iodinize or something, I can't pronounce.
The IC plug?
No. Like if you cannot insulate the whole frame because it's not all connected electronically, is that what I'd say?
Yeah.
Then obviously any part of that frame that goes live with power, it's only going to affect that part of the frame. It's not going to travel around the whole frame. So in effect, it becomes less of an issue that you need to earth. My frame is non-ionized, so it's all interconnected. So all I've done is connect.
Oh, anodized.
Anodized, sorry, yeah. All I've done is I've connected a T-nut to the frame and grounded it to my power supply, because everything on my frame is a circuit. Basically, it's electronically connected. If I was to put current going through the frame, it would go around the whole frame. But if I was to do the same to your frame, Shay, it would only stay within that one section because it's insulated from another section. So if you did want to isolate anything, I would isolate 2 or 3 bits of your extrusion that are close to your board and power supply, because they're the only ones that are likely to go live. That makes sense?
It's true. And it actually, I mean, you talk about, just 12 volts going through you, not the 120.
Yeah.
So, I mean, you do those 3, but I think a lot of people leave out if you notice on the power supply that I have in the screenshot here, I'll show again. That power supply has an earth connection on there.
Yep.
And I don't know why. I think a lot of people actually leave that out.
Yeah, I don't know why. Because that's why I wasn't sure whether you had it in the States. And I wondered if that was why.
No. So I think just people hook up a common two-prong plug and just go straight into positive and negative here, or live and neutral. And they don't use the proper 3 prongs and go to the earth.
Yeah.
So that's the other reason I like this IEC plug too, is because actually you have to connect this ground or it doesn't work.
I would always recommend using earth because it's your fail-safe. That's what it's there for.
Yeah, and then I've seen people too. So sometimes you take the 3-prong from here and use a 3-prong to 2-prong adapter. Don't do that.
Yeah, that's just totally different.
This is wrong.
Yeah. End of the day, you want to be safe, guys. We all have basically fire starters, which is basically what a 3D printer is. If left unattended and not monitored and not looked after, that's basically what it is. It's a fire starter. So let's be as safe as we can with it.
Yeah, I'm actually going to put a second power supply here on the diagram just to keep it simple with the way that yours is set up.
Okay.
And then I'll put an SSR in here in line, so that way people know that we're not. I mean, the important part here is we're not powering directly off the board. We're not using that circuit. We're actually using an SSR.
Yeah.
Right, because yours is 120. Yours is 120 volt too, right?
No, 240.
240. Okay, so it's easier in your case. So yours is 240, and you're off of mains. Mine is 120 off of mains. The only difference is mine's a 2 zone and yours is a single zone.
Yeah.
So there's no second power supply.
Oh, sorry, no. My heat bed is powered from a 12-volt power supply, but obviously the 12-volt power supply is rigged up to the mains, like any 12-volt power supply.
Okay, so let me just see if I can draw this right. I'll try to draw by yours first.
If you imagine, all I have is I have a relay cut between one of the leads coming back from the hot heat bed to its supply. Does that make sense? So you imagine a circle. All I've done is cut a line in that circle and put a relay there, which is controlled by the ramps.
Yeah, let me see if I can draw it out here. I think that'll help.
You have to get this right though, because it is a bit tricky.
Oh yeah, I agree.
There are diagrams on the internet as well if you.
Yeah, the only thing, the relays on the internet fine. You want to switch your live. A lot of them for me switch ground.
Yeah.
So yeah, you want to switch live.
Yeah, so they're called something naturally open or naturally closed.
Normally open.
Yeah, sorry, normally open is it? Sorry, normally open or normally closed. You want it normally closed and then opens under the situation you want it to open under.
No, I think it's the other way around. You want it normally open. That way, if it fails and it dies, it's an open connection.
Sorry, yeah, I'm saying I totally agree with that, but I was just we call it slightly different.
Oh, you guys in the UK call it differently?
Yeah, we say I think naturally open means that you're naturally giving it power. I think. No, I'm confusing myself. No.
Yeah, I think you're confused.
Yeah, I am confused. Yeah,
it can be confused.
Normally open, normally closed. You want it normally open, which means there's no power going to your electronics.
Yeah.
And normally closed means there's constant power going to your electronics until you tell it otherwise. So you want it normally open because you're going to tell it when to power.
Yep, and that way, when in case it fails and there's a failure in the actual SSR relay itself, it'll die open, which means that there's basically no power to your electronics, which is good because then that means that you're
not necessarily though. They can die closed.
Oh yeah, I agree. Yeah. They should die open though.
Just as a thing, I've posted a video. I actually have two relays in series that both have to function for the heat bed to work. The reason I've done that is if one relay was to die open, the other relay would switch the heat bed off like it's supposed to. The odds that they're both dying at the very same time are very slim. So just as an extra safety factor, I've got two relays in series. But I've used automotive 12 volt 40 amp relays, which have been super duper. They're mechanical relays, so you can hear them switch, but I quite like that because I can hear when my heat bed's coming on and going off again. They're not loud.
Yeah, actually,
we've covered all these in 101 videos, haven't we, Shay? I think.
Yeah, we did. Mine are mine's a solid state, so mine you can't hear it.
Yeah, but if you're buying the one that Shay's showing you there, it's got to be an original one. Please don't buy a Chinese clone because they get incredibly hot and they'll burn your house down.
Should I just change this and put the good one here?
Yeah.
The up to 22 one.
Yeah.
Okay. And Bill asked a question about why I forgot about relays. How to switch live. Okay, so Bill, I'm not an electrical engineer. I won't pretend to be, but I'll give you the answer that I understood, at least from much smarter people than me on the builders group. You want to switch live because that's the standard way that's done, I guess, according to like the electronics standards or the way that's taught in schools.
Yeah, because you don't want it.
You're supposed to always switch the live signal and not the ground. So I think it comes from the fact of safety, and if it dies,
the ground signal
dies in a closed state. I think the idea is that I think the idea is that you're cutting the live, which is originally the electricity starts flowing on the live. So by switching the live, you're switching it in an earlier phase before it ever actually gets to your electronics. Which I think that if you switch on the ground, it's the other way around. The electricity is actually flowing through your electronics, and as it's coming back through the ground, that's when you're switching it, which is you're cutting the circuit, but there's still power flowing to your electronics. So I think the idea is you switch it on live so that your electronics never get that power. I think that's the way that I understood it. So hopefully that makes sense.
Yeah.
And I'm putting the Opto 22 because that's the the one that we have on the bomb. They are expensive, but I think $20 or $30.
It's better than your house burning down.
Yeah, I have two of them. So
did you use two in series like I did?
No, I did not. I have one on the heat bed and one on the
power supply.
No, so I have two on the heat bed because I have two zones.
Oh, sorry. Yeah. That's right. Are you just going to quickly comment on how effective your two zones is, and would you go to?
Sure, it's not worth it.
Okay.
Well, I'll put it that way. It's I think it's a lot of work to set up both of the heat zones. And at least I have not even tested the single zone yet when the printer was in a all right, let me go back. When I was testing the single zone out, the printer itself was in a room that wasn't temperature controlled. So the temperature in this room that I'm in right now fluctuates between, say, 7 degrees. Actually, no, in the winter between 2 degrees to 15.
Yeah.
And then in the summer between 40 to 20. So that huge fluctuation was just causing a huge fluctuation in the metal plate that I have on the bed. So remember, we're using like a 5mm sheet of aluminum. So in my case, when I would use a single zone, it would take an extremely long time to heat up the two zones to the point where sometimes decoupling because it wouldn't raise 1 degree in a 30-second period. So I couldn't even use a single zone in this room. Now I do have the printer in the basement where it's actually temperature controlled, and it's usually about 23 degrees or about 75 degrees Fahrenheit. And I could probably use a single zone, but because it's actually a physical switch on the side of the printer and I print remotely most of the time, I just always have it set to the dual zone. So I think if I had it G-code controlled, which eventually is my goal, I might use the single zone more often. But for now, I don't. I just keep it on the dual zone. So if you have the money and you have the time and patience to do the dual zone, I think it's worth trying and having that experience. But I think if you're not, I think just starting off, just go with the single zone. It's much easier. I would still go with the single zone mains powered, and with the relay, not a 12 volt.
Cool. I don't have any issues with the 12 volt. I don't have any issues going 24 volt. I would go 12 volt again. But to be fair, on my next one, I think I'd go 240 volt just to see how that system works. I don't think really there's anything to gain my side of things from either or, but I'm willing to try the mains powered, I think, next time. The reason I got 12 volt is because I got it so incredibly cheap. I think it was like $26 for a 300 by 300 heat map, so it was worth the risk for me.
Yeah, and I think people might ask too, why do we have the solid state? If you're powering if you have a 12 volt heat bed like you, and you have a 12 volt power supply, why not just connect it straight to the ramps and use PWM, and have the firmware actually control it? Not the firmware, but have the power running through the 11 amp circuit that's on here. So the simple answer is, if you have a 300 by 300 bed, or actually even more, if you have the 40 by 40 bed, you're going to pull more than that 11 amps. You might be a period where you're running close to 8 or 9 or 10, but these poly fuses,
20 amps.
Yeah, so these poly fuses are supposed to be 11 amp poly fuses, but in general, they sometimes tend to be 10 or 9 or 8 amp poly fuses, and they're not always very accurate. So I think when we found, as we were doing the research and going through this, that it's better in this case, because the heat bed can pull 20 amps, to just run it off of a solid state and use bang bang. Yeah. Even though you're still running off of a 12 volt power supply. Now, if you're going 24 volt power supply, that might be a different story, because then your amps might be less. But in the case of a 12 volt power supply, I think still to use a relay, even like Colin has, a mechanical relay is fine. And use bang bang. The heat bed doesn't need to be dead on accurate like the extruder. So
be careful in your firmware as well. I think they've solved the issue, but when I first set up my firmware, although I had it set to bang bang in firmware, it actually saved as PDM, is it, or PVM? I can't remember what one it's called.
No, so it's fixed.
Is it fixed? Okay, I won't mention it then.
Yeah, and then just for clarity too, the firmware, we have everything set to PWM, not PWM. PWM, not PDM.
Sorry, yeah.
All right, so I think as far as the diagram goes, I think
Pretty
that's
much there.
fairly close.
I don't think you could. It could be more detailed, but I think what we've gone through, if you just reference what we've told you, you'll be fine.
Yeah. All right. I think we'll end it there.
Yeah, I think we'll end it there. I think there's a good hour.
So Bill asked, really only for the heat bed. Yes, Bill, really only for the heat bed. We don't use relays anywhere else. There's no need to.
Yep, because the ramps board has the ability to control. Cool.
All right.
Thanks, guys.
That's it, guys.
Time.
Yeah, stop it there.